developers think login is really simple. User enters password, database checks it, and done. But in real systems, authentication is one of the hardest systems to build. Companies don't get hacked because their UI is ugly. They get hacked because their authentication system was poorly designed. So in this video, we'll go step by step how authentication systems actually work, and we'll cover a set of events like how passwords are stored, how server remembers users, what exactly is JWT, how it works, how login with Google works, what is OAuth, and a lot of things. So you will, by the end of this video, you will understand authentication as an actual system, but not just as a code. So before actually going into the deep details, so first let's understand how it actually works. We need a proper mental idea ki how it works. So authentication always follows the same pattern. Pehle user comes to the website, the server requests a proof for that. User comes and proves their identity. The server records that proof somewhere and somehow. We'll discuss that further. And every feature includes some factor, some constraint that represents the proof that of their identity. The server verifies it again and again how many times you visit the website, or in a particular interval, however we said it. So authentication is not just a single event, it's a continuous loop which goes on until you use the website, or how many times you log in it. So whatever we discussed today will fit into all of those. So how do you actually think this works? You are a website designer and I am a user. Suppose I am coming into your website, I enter your password and you store that password raw and directly into your database. That's not how that works, because as a user, you I can't compromise my password to you. If you can clearly see my password, then what is the use of a privacy? Because if you know my username and password, you can try it in different locations too to access my data. So there should be some factor or feature which protects our password. So there comes the topic called hashing. So before actually deep diving into hashing, we have a concept called encryption. You might have already ever heard this word. WhatsApp is end-to-end encrypted and so on. So encryption is, suppose you have a set of password which is password, password. So over here you will set a key. The key can be, you will add 1 to each and every letter of the word. So for P becomes Q and so on. So the key plus 1 becomes your main identity. So you can store passwords this way too, but if the key gets exposed or leaked, this causes major privacy issues. So we have a concept called hashing. Hash is an output of a special mathematical function. The critical property of hash is you cannot revert it. It is only one way. Once you hash a password, it cannot be reverted. Hash is an output of special mathematical function. If you input a password, it produces a fixed length of characters. A critical property of hashing is its one way. Suppose in encryption, if you have the key, you can revert back the particular word which you stored as password. But in hashing, it's not that way. If once you hash a password, it's completely impossible to revert it back. So this is what it makes hash so critical in nowadays. So during logging, the system doesn't check the password directly. It hashes the password the user entered and compares it with the stored hash. So suppose I am a user entering into your website, and I sign up and enter my password. So what your system must do is it must hash my password and store it in the database. Whenever I'm trying to log in or do any other stuff, you should just compare the entered hash password with the stored password. There are several functions which are available in bcrypt and all of those, which can help us find which can help us compare the both passwords. So this is how password hashing basically works. You have a password, you send it into a hash function. Bcrypt is a basic password encrypting hashing module. So hash password looks something like this. These are completely random characters which you can see everywhere. A person cannot easily reverse the hashed password to find out the real password. So suppose in this also we have a case key. Suppose we are using a particular website and two users have the same password. So if their hash is the same, then it will be very difficult to compare, or it will be easy to know if my password is the same and your password is the same, and their hash comes out to be the same. Then it can be decoded that both the passwords are same and a pattern can be found. So in hashing there is a concept called salting. Salting ensures that random characters are added in between the passwords wherever possible. Suppose over here you can see between A and B there are multiple characters and numbers added. So over here we do the same. We will dive deeper into salting further into the video. So for now, salting prevents two same users having same password to collide with each other. This makes external companies or external user to completely, this avoids the external user or external any hack, or if anybody is trying to hack completely, they cannot at all decode what the hash password is actually is. So this is a major security feature used in each and every website nowadays, and this has actually helped people saving their password. So normally for hashing, speed is actually bad. So this is an important point. Normally we want algorithms to be fast. Wherever we run a code, we generally try to reduce the time complexity and make the algorithms to be fast. But we generally want this bcrypt algorithms to be a lot slower than the actual whatever algorithms are there, because for passwords, fast hashing helps attackers try billions of guesses per second. Suppose like if the hashing speed is really fast, I can, if I'm a hacker, I can try multiple passwords combinations, billions means it's a lot. So we intentionally, the creators of hashing, the creators of bcrypt and script, they intentionally made the hashing to be slower so that these type of attackings can't be done. So the real password pipeline looks like user enters password, it adds salt to it, and it runs slow hashing to it, and it stores hash and the salt in its internal database and the database. So this is how identity proof begins. So this is how hashing actually works. A user enters a password, the password gets salted, so random characters and numbers are added in between the password, and after that slow hash gets run. After that it internally stores the hash and the salt separately into the database or into its internal components. So that's how actual identity proof begins. Okay, so server verified your password, you logged in, but what happens next? You, as a website user, you click on another page, you refresh the website or send another request to the database or the backend. So you don't re-enter your password each time you send another request. So how does the server remember who you are? This is second layer of authentication. So this is where a new concept begins: session management. So the traditional solution for a website to remember even after you log in is called sessions. So when you log in successfully, the server creates a record in its database representing your login. So this record is called session. It contains information like when the user logged in, what is the metadata or IP, what is the device information and all of that. When the session started, how much is the duration of the session. So then the server generates a random long character string called session ID. This session ID is sent to the browser in form of a cookie. The browser stores it as a cookie, and whenever you make a request in the website, the browser sends the cookie automatically to the backend. Then the backend verifies the session with the stored session in the database, session ID with the stored session ID in the database. After that, it proves your identity and it gives you the requested information. So this is how it basically works. After after all this is done, after session ID expires or after you log out, the server automatically deletes the session record The cookie points to nothing. The user is logged out. Sessions are reliable and secure, but they don't scale perfectly. Every request requires looking up to the session store, which computes a lot of time. And in huge distributed systems, this can become really expensive. That's why modern real systems use something like token. So we will discuss what exactly tokens are. So this is how session-based storage systems actually work. First, your website checks for every small interval. Your website checks if you are still logged in. If you are still logged in, it resumes counting. Counting means over here that you again check if you are logged in. The loop continues. So as you can see, if you are logged in, you resume counting. You again it checks if you are still logged in. So if you are if you are not logged in at any point of time, the session times out, and after that there is a wait time of 300 seconds, so that the user or whoever uses the website, they can, it gives time for them to log in. If they are logged in, it again starts this loop. It resumes counting. It checks if the user is still logged in, and after that, if the user is not logged in, if even after 300 seconds, 300 seconds is a general time used for this. You can set it to whatever you like. So afterwards, if the user is not logged in, it pauses counting completely, and till another login, it does not start the login. So so this is how the basic session storage systems work, or they are intended to work. So we have discussed about cookies, that server sends a session ID to the browser in form of cookie, and the browser again sends back the cookie to verify. So this is what actually happens. So as a user, you request the browser to log in. So after authentication, the backend server sends you back a cookie, which is a session ID in this case, or whatever it can be, whatever, as we discussed, as we are gonna discuss, it can be a token too. So that if I again want to view a page, I do not need to log in again. The browser automatically sends the request plus including the cookie to the backend server. The backend server verifies if the cookie is same as a session ID, and if it matches, it sends the response which they have requested. Suppose it has loopholes too. Suppose if I got to know about your session ID, so you are a user and I am a user, I got to know about your session ID, so I can easily manipulate your data using your session ID. Like I can upload whatever I want, I can check your data, and I can do whatever. So here comes the most important part of this authentication, JWT authentication. So JWT is a way to store data inside of a token, instead of storing it on the server like we did on the session based authentication. So in session based authentication, server stores a session in the database, which computes a lot of data. Suppose millions of users use a particular application, so in that case, each for each user there should be a separate session ID and all of that, which computes lot of space. The client stores only a session ID. As we discussed, it can be vulnerable too, but in JWT, the server stores nothing. The client stores the whole authentication token. Only the request carries this token, and the server only verifies it, does not store it. So this is called stateless verification or authentication. So JWT has three main parts: uh, the header, payload, and signature. These we'll discuss each part one by one. So what the header is: header contains metadata about the token. The metadata is things like what the device is, the information about the device, what algorithm is being used to, we don't need to dive deeper into the algorithms right now, but what algorithms are being used to store the tokens and all of that, the type, the type, and a few more things. So it basically contains of things like this. Its basic syntax looks this way, the header one. And let's understand what exactly payload is. Payload is the very important actual data stored inside the token. This is what most people misunderstand this. Like payload is just simply a JSON object containing claims, but this is not only it. Claims are statements about the user. The typical payload consists of user ID, role, permissions, expiry timestamps, and all of that. So these are actually used to store whatever the information about the user is, and we can reuse this information to verify and check each and every time. So payload is always encoded but not encrypted. So we can easily decode the payload if they are not stored properly. Like cross-site scripting attacks can also be done. We'll discuss, we will not dive deep into this scripting attacks. We will discuss them in a separate video if possible. So anyone can decode it. So that's why we don't store passwords or anything into this payload. We just simply store the user about type about the data about the user. So example, his role, his user id, any permissions he has, a timestamp issued, how much expiry time they have, and all of that. Payload is actually visible as we discussed. Now next comes the signature part. Signature ensures that the token wasn't tampered with. It ensures that the suppose you are cross, as we discussed about the cross site scripting attacks. I attack on your website and I try to tamper your token, and I try to access your token. So signature prevents that. It's created like it takes the encoded header, it takes the encoded payload, it combines them and hashes them. So as we discussed about hashing, it is an irreversible thing. So it can only be compared, it cannot be reversed back. So this is how it works. The signature is actually really important part of the JWT authentication, because this is what it keeps the actual data, our data, protected. So only server knows this secret. We can define a secret in our website. So we generally store it in .env file, so that if we make the repository public, the people out, if people outside can see our secret, then we are completely compromised. So we generally store this secret, so-called secret, in our env files. If someone tries to edit the payload, the signature will not match because of hashing. So this is how server actually detects tampering. And it if it detects tampering, it goes into high security mode and it starts checking each and every part. So let's walk through to the exactly happens through the login. So first, the user, suppose I am the user, I entered my username and password. Server verifies credentials using bcrypt algorithms and all of that. So if as a website creator you has the particular password, so after that server creates a payload with user id, suppose if you have any role, and expiry time if you have provided any, and after that server signs it with a secret key, the key which you have stored somewhere. So that token is sent to the client or the browser, and if whenever you are trying to open a new page or request any something, the browser sends the token to the website, to the backend server, and it gets verified and the response gets sent. So this is how it is actually stored, and the data is protected this way, so that nobody can access each other's data if somebody is in the database. The how request flow actually works is, JWT actually works great in distributed systems because no session storage is needed, no database can look up per request, and any server can verify token using same secret. JWT is actually commonly used in microservices, APIs, cloud apps, and most of the real backend applications which you use. You might create small projects and all of that. You can use JWT verification in that too, to protect the data of your users. So JWT is not a magic, it's just a revolution which was brought up by people after their data being compromised. This was just like a solution. So as we go step by step, this is actually a very good solution for this. With session based storage, if we delete the session, the user gets logged out instantly. But in JWT, if the token stays valid until expiry, if you set a expiry of 1 hour, 2 hours, 3 hours, it stays so. Or if the user logs out, the token expires, and if the user logs in again, the new token is sent back. So nothing is, the user's browser storage is being used rather than the server database storage. So this heavily saves the computational storage and computational time. And so JWT is powerful because it removes server state. It is a stateless application. So this is like how header, payload and signature actually look like. Header looks like this, as we discussed. It's some particular algorithms, and whatever the type is JWT. And the payload looks like this: the name of the person, the expiry, like how much and how much time the expiry will be happening, and some parameter. You can use any parameter over there, and over here they have a role. Suppose this is called role based authentication, and if you want to check the role of the person, you can verify it over here too. And the signature, as we have discussed, it combines the header and payload, and it hashes it with the secret key which we have provided in the .env file, or wherever we have discussed. And over here you can see how it is actually being worked, the workflow. So if as a user you log in using username and password, the server validates credentials, creates and signs tokens, and it sends token to the browser, or it sends to the browser. After that, if you get any info, it sends the token too. So you validate the token and send data. If the token isn't validated, you send that you're unauthorized. So this is how the basic workflow works. And so yeah, this is the same image of the similar image, so depicted in another way. So sometimes while logging into an unknown website, I don't want to give my password to them. We don't know how, if they are hashing it or not. So this is where OAuth comes in. You might have seen things like continue with Google, log in with Google, sign up with Google, and all of that. That is called OAuth or authentication. OAuth was developed by Blaine Cook, which person of Twitter, and few other people in 2006 to 7. So over here, authentication, we are gonna know how OAuth actually works. So to understand OAuth, you first must know 4 roles. There are 4 important roles. First is the resource owner. Suppose you are a person who is logging into a website, which consider any website. So first you are the resource owner. You have a Google account with Gmail name and Gmail ID and your profile picture. You have these 3 resources with you, and you are the owner of those resources. And then there is the client application. The website which you are visiting, which wants to access your data from this Google. So there is an authentication server. The third role is authentication server. The authentication server in this case is the Google's authentication server. If suppose you want the website to access your data, so that particular website goes to the authentication server to access the data. We'll learn about that soon. And there is a resource server where actual data is stored. There is an authentication server which verifies the data, and there is a resource server which has your data, so that sends you. So we will actually understand how this is working. So let's walk step by step. First, as a user, you click login with Google. Here's the actual diagram with which we can understand. Suppose you are the user. You are the user, and you want to log in with Google. Let's take Google for this example. You can log in with GitHub, Twitter, and all of that too. So each one has its own OAuth services. So it asks you if you want to link your service. The first step is the app, the website which you are trying to log in. If it asks that if you really want to log in with Google or not. If you click yes, then afterwards the app makes a request to the resource owner's authorization server. The authorization server then verifies, returns to you that returns to the application page key. Are you really trying to access your data? Are you really trying to give your data to this particular website? If you are already logged in, or if you approve that I am willing to give, then this sends back the request to the authorization server. You send let's understand this clearly once again. So you want to log in using Google to a particular website. Let's take Instagram for this example. You want to log into Instagram using your Google account. So you say to Google that I want to log in. It confirms with you the yes or no message. You click yes, I want to log in with Google. Afterwards, Instagram sends a request to the authorization server of Google ki yeah, this person wants to log in using Google. So Google authorization server sends you back a request key. Do you really want to log in? So if you click yes again, or if you get an approval proper, if you enter a login ID and password, it returns to the authorization server and it says ki this person wants to log in. So afterward it goes to the resource server. In this resource server you get an access token. Like you can understand how it works in a restaurant. Ki first you talk to the waiter. The waiter gives you a token. Afterwards you go take the token to the chef. The chef gives you the restaurant item. So this works the same way. The resource owner server, you go over there. Over there you will get first the authorization token. So first the code is sent. Authorization server sends a code to the resource owner server. The resource owner server. So after you confirm that you want to log in, the authorization code is issued. Google redirects the user back to the client tab. Instead of sending data directly, Google sends a temporary authorization code. This code is short-lived and single-use. This is not yet the access token, which we have discussed about the waiter and all that. Now the client tab makes a server-to-server request to Google. It sends authorization code, which the authorization server sent earlier. It sends a client ID, client secret, and redirect URL. So this proves that request is coming from the real app. The Google verifies everything. If it's valid, Google returns access token. It returns access token so that we can actually get the resource from the resource server. So if it is valid, Google returns the access token and the refresh token. The refresh token is a token which if you want to get an access token, you have to get a refresh token. The refresh token always get refreshed बहुत बार refresh होता रहता है. उसके बाद after that you can get an access token. Like let's consider it with a real life analogy. You cannot always go to the chef and ask stuff. So first you ask the waiter to buy मुझे access token है. So the waiter will give you a refresh token. If you give the waiter a refresh token, he will give you the access token and you can take that access token to the chef. So this prevents any user from creating multiple requests over a long period of time. This is short lived. So there is an expiry time. The access token lives only up to this expiry time, but the refresh token stays forever. And the access token is now used to fetch the actual data, your user ID, your email, your profile picture, and all of that. Now Google checks the token and scope. If it is valid, it returns user data. The Instagram app now knows your username, your name, your ID, your profile photo, and all of that. Now token expiry. As I said, access tokens are short-lived, so we use refresh tokens. When access token expires, client sends refresh token to the auth server, gets new access token again, as we discussed in the waiter one. So now let's come to the real part. Why OAuth is actually secure? OAuth improves security because passwords never leave provider. Token can be scoped. Passwords like तुम Instagram को password, you are not giving your password to the Instagram, and tokens can be actually scoped, and tokens are also expire, and they can be refreshed using refresh token. Access can be revoked whenever the authorized resource owner wants, and phishing risk is actually reduced because Google's authorization servers are actually powerful than we building our own authorization servers because it is an established company. Now let's learn about OAuth versus JWT sessions. OAuth is an authorization protocol. JWT is token format often stored inside OAuth. Sessions are server stores login state. We have discussed three of these. So OAuth answers, can this app access this data? JWT answers, how do we encode the access token. They solve completely different problems. Like you can use if an app, if you trust the app, you can use login and password over there. They use JWT services to store and secure your data. So here's an even more clearer workflow. So this is your app. Suppose you are building an app and this is Google servers. So your app sends a request token key. You are trying to access the data of your data, and the user gets a login consent key. Do you really want to share your data with this? Then this actually happens in milliseconds, but this big process. Server sends authorization code, this sends refresh code, that it sends access code, and this access code can be used to call Google API. So this is the actual workflow which we have been discussing since earlier. So this is also the similar workflow.
So now we are starting with code implementation, how the code implementation actually looks like. So first let's start with session-based authentication. Over here, so let's first start with server.js. So here first we import, first we obviously install the required modules. So after that, we are importing Express, and Express session, there is inbuilt feature of Express which can access sessions, and after that we are accessing .env. As we discussed before, .env is required to store the session ID, to store the secrets and all of that, to store the encryption secret and all of that. So over here we use routes. So if we go into the routes, so here again we implement Express, and we, as discussed, we implement bcrypt, which is an hashing algorithm, and we get a middleware authentication. So first let's go to middleware/auth.js. So over here, if required, so the rec.session is from the request itself, which the browser or client is sending. From that we, if they are there, if request.session is there and request.session.uid is there, if both of them are there, if only then we will send to the next one, or else we will send that they are not authenticated. So after they are authenticated, we then move into this. So we call next function over here. If they are authenticated, so over here we come, and for now I have just used the local storage or array. Generally databases are used, so I did not connect to databases yet, so I'm normally using this. So router.post, this is basic router functions of Express router Express. So we created a endpoint called register. So I guess most of you know about REST API. So this is an endpoint called register, and we are trying to first post the user. If we are trying to access the username, email, and password from the body, which is automatically sent from the client, from the front end or front end server. If they are existing user, we send an error, user already exists. If they are not an existing user, then we hash the password. So this is the main part which we are talking about, how it is being hashed. So bcrypt internally hashes the program, which we talk. Hashing is an output of a mathematical function. So it performs. This is salt. So like the salt, much like we have to add 10 random characters in between the particular password. So this acts as salt. This is salt, and this is the password which user has provided us. So after that we create a user object with their ID, username, and hash password. We do not use original password because to protect the identity, obviously. And we push the users to the database. For now we are using the local database, but we can use the proper relational or non-relational database. So after that we are storing this, we are getting their user ID from their session, and we are sending the response that message user successfully and all of that. If there is an error, we try to catch an error. So the same goes for API login. API for login endpoint. So we try to get the email and password, and after that we find if email is not there, we send error, email is not found. And to check if it is a valid password, we again use bcrypt.compare. So this is what we have discussed. So bcrypt.compare the password which user has sent versus the password which was available in our database. So we compare both of them, and if they match, the bcrypt performs the same sorting operations as before. That we will discuss in separate another video, exactly how bcrypt works, and many other internal algorithms, how they work, we will discuss in the further video. So that's the thing. So password and user password, it checks if there is any error. It they see if it's not a valid password, we send an error, it's invalid credentials. If it's a valid password, we store the user ID and we send the response key. Yeah, this is user is stored login successfully, or else we send a server. Same for the profile endpoint. For the profile endpoint, suppose they want to check their profile, we get their user ID, and after that, if they are not there, so we send user not found for that particular session. If the user is not found, if the user is found, we send their profile details, log out, we destroy the session details, so the red dot session. So whatever the session details they have stored, we destroy them completely and remove them from the database. If any error occurs, it shows they could not log out. If it logs out, it deletes the session ID and all of that from the database, and it logs out successfully. So this is for the session based authentication. There is nothing more than this. So afterwards, let's go to the JWT authentication part. Over here too, we have routes, server, basic server.js and normal, all of that. So over here we are requiring express. We are requiring .ini. As I said, we have to store JWT secret over there. JWT secret and JWT expressing, because the expressing is also a parameter which you don't want to know. If you want to change it, you don't want to always change it, so you can change it over here itself. So the middle, let's come to the middleware. Okay, let's try this first. App.use, we are using normal routes over here. And now coming to middleware, we are verifying the JWT token. So this is how JWT token is actually verified. So we get the token from the suppose a user is logged in, so we get the token from the browser and client itself, and we verify the token over here. So first let's check how it is being stored. So yeah, over here we import JWT and all other bcrypt.js and all other required modules, and after that we use the router. We, as I said, we are using local storage, and for register endpoint, we are doing the same things as above. We are checking if user already exists and all of that. We are hashing the password. We are pushing it, and after that here comes the important part which we are here for. So const token equals JWT.sign. We have discussed that it combines the header and payload to sign the header and payload and JWT secret to sign the particular token and sends it to the browser. So over here this is the payload, this is the secret, and this is the header, this is payload, and this is the secret. So over here ID is user ID, email is user email. So we are storing all this info. The payload must not contain sensitive information, as we have discussed. So this is headers. We are not don't have headers right now. We generally don't need to mention headers anywhere. So after that, if it is successful, we send the user register successfully. If not, we send another. Now coming to login, here is where we require middleware. So we basically test all of this. After that, we test if the user is valid or not. Like the bcrypt one. Now comes to the JWT part. After signing in, we first over here, if we can see, we are checking if the user is like if their token which they have sent is actually which we have or not. So over here we verify the token. So const equals verify. We use the verify function of JWT. You can read the documentation. So dot user ID, we store the user ID from which we got, and we send the whatever we send the response for whatever request they ask. So for profile, Also, we do the same. We verify the token, and then we do whatever things are to be done. So this is for the JWT authentication. OAuth is nothing much. So first we need to learn about passport.js. Passport.js is a framework which similar to Express. Like for configuring actual authentication, we need to write almost 2 to 3 thousand lines of code because it's a really big implementation. So Passport gives us a ready-made template in which we can use our from whatever we are getting from the Google Cloud API console and directly contact with the OAuth. It helps us directly contact with it, and afterwards over here the same structure is over here. If it is authenticated, we return next, and coming to the routes. Over here we import the modules and is authenticated and all. The router, so get passport.authenticate. We use passport's default functions and all of this to use the OAuth. This template is already provided in passport.js. You can refer the that thing. So these are all really important. This have to be stored in the .env and have to be added in the Git ignore. This repository is not currently published, so this is not in Git ignore. So this has to be added in Git ignore because this is really sensitive information and specific to the particular website or project only. So over here we need session secret, we need Google client ID and all of that. Session secret, this is storing in session base one now. So if it is storing in session based on, so all of these are basic ones. As I said, you will get the template. So that's it for code part. So thank you for.
So I would like to conclude the video over here. So thank you for watching. So basically we have understood in this today's video that there are different kinds of authentication, mainly 3 types of authentication. One is session based storage, one is JWT based storage, and one is OAuth. According to me, most secure one is OAuth, and the JWT is also very secure, but they have their own use cases. JWT is used in some cases and OAuth is used in some cases. So obviously they have their own implementations, and as we know that this is for the OAuth, and our next topic and next video will be about how databases work internally. So over there we will discuss about B trees and all of that, how actually SQL is just a query machine and not actual databases and all of that. So if you are actually curious about this stuff, please explore about passport.js and authentication. I'll try to host this repository and in GitHub, and create this as a repository, host this and put it in the description so that you can verify all of this. I will make sure to add, if any of your project, make sure to add .env and do the necessary changes. So this is for the passport.js middle. So node modules, the basic node modules, these are also generally added to be in .gitignore, because there is no need to push node modules. They are actually big files, and you can comment in the comment section if possible if you have any doubt about regarding any particular project, and if you want me to create any particular topic, and we can also discuss about various stuff regarding the authentication itself. So thank you for watching this video. So before concluding the video, I would also like to inform that I'll be posting this, I need you guys to actually try out the whatever the implementation is given here. This is actually very interesting. The JWT I find more than session based and authentic OAuth based. The JWT based thing is really interesting, and like to imagine this. So how actually things work in the backend, if you really want to know that, you can comment for the next video, and you can explore on your own too. There are several documentations ki how JWT works internally. There are like what exactly is signing, and mainly for hashing too, how hashing works internally. If there are any math enthusiastic students, you can explore, you can open hashing documentation. You can I guess there is a book for that created by the
like written by the people, so you can check that key what even I haven't checked that out. If I get time, I'll try to explore all those things too. So hashing is also really a very cool topic to explore. And about passport.js to OAuth, how exactly OAuth works in the background, what is that 2 to 3,000 lines of code which I mentioned about. You can also check that too. And like the middleware functions, if you have any doubt about how, you can also check out how Node.js works. So these are all like you can see homework type of things which can be done after concluding this video. So if you need any tips and tricks about VS Code and all of this, so you can comment down in the below. So done.